start this. We're on. Okay. So we're going to do three things with piecewise defined functions. One is we're going to learn how to graph them, and you'll see there's only a few problems here, 25 to 28. You should do all of them. We're going to define the domain, the range, and the intercepts of piecewise defined functions. So here's an additional 10 problems, and they have certain parts A, B, C, and D. And it says just do the odd ones. So there's only 5 problems here. And then I want you to be able to, if I give you the graph of a function, this is where you got to know your library of functions, well, one place. And I want you to be able to write that function algebraically. That's a little bit tricky. So you should definitely do these problems here, 41 through 44, just 4 problems. So let's take a look at a piecewise function. So here is the example of a piecewise function. You see why I told you, Katie, that you'll know when we're there is because this probably looks a lot different than any function you've ever seen before. Yeah, a little bit different notation, but it's not. It's really actually pretty straightforward, piecewise defined function. So what a piecewise defined function does is it's defining the function differently on different parts of its domain. So I'm looking at this function. It's just a single function, f of x. And I say it's equal to, but I got a bracket because I'm going to divide its domain into 3 separate pieces. And I'm going to define it differently on each piece. So when my x value is less than 0, I want my function to be x squared. When my x value is equal to 0, I want my function just to be simply the constant 2. And when the value of x is greater than 0, I want my function to be x plus 2. Now, sometimes a piecewise function will have 2 pieces. Sometimes it'll have 7 pieces. There's no rule that it has to have 3. Just in this particular piecewise defined function, it has 3 pieces. So let's kind of make a little bit more sense out of this. So I am Marissa. You're going to help me with this, okay? Where'd you go? There you are. I see you now. Okay, Marissa. So the first thing I want is I want to know what is f of -2. So Marissa, I want to first find out, well, is -2 in this piece, in that piece, or in that piece? So which piece is -2 in? Is it in the top one, the middle one, or the bottom one?
The top one.
It is in the top one because -2 is less than 0. Very good. Are you good with that? Okay. So if my x value is less than 0, then f of -2, I'm going to use this piece of the function to solve it. So I'm going to say, well, then it is -2 squared. So f of -2 is 4. Marissa, that makes sense? Everybody else, that makes sense? Question? All right, let's plot that point then. So I have my x value is -2 and my y value is 4. That point's going to be right here. We'll make that in blue since that's the blue part of the function. Okay. So next piece. Well, I want to find f of 0. So f of 0. Let's ask somebody else here. Sophie, which piece does x equals 0 go into? The top piece, the middle piece, or the bottom piece?
The middle piece?
Yeah, it goes into the middle piece. So what is f of 0 equal to? Can you tell me?
0.
Nope. What is
Oh,
f?
2.
Pardon me. Yeah.
2.
It's equal to 2, because what my piecewise defined function is saying, it's as if I wrote it like this. It's as if I said, okay, f of x equals 2, and you're finding out what is f of 0. Well, I mean, f of anything in this particular piece equals 2. Is that clear to everybody? Yeah, kinda. Okay, so I'm going to plot that point. 0, 2, that's right here. Okay, now I need to find f of 3. So f of 3. Marissa, which piece is x equals 3 in? Is it in the top one, the middle one, or the bottom one?
Bottom.
It's in the bottom one, because these are for my x is greater than 0. So f of 3 equals what, Marissa?
5.
Very good. Because this is the function I'm using. So 3 plus 2 equals 5. So I have the point 3, 5. So those are 3 pieces, 3 points on my function. So I'm going to pause right here for a second and make sure that everybody's following along. Got a question? You can stick it in the chat. You can ask me. Yeah, Esme.
What's like the question? Like, why are we like graphing? What are we trying to find again?
Okay, so I was looking at A right here. It said find f of -2, f of 0, and f of 3. So I found those points, and then I just decided to graph them myself.
So are we like finding like what like shape it is? Or...
Yeah, we're going to do that when we get to part C.
Oh, okay.
Okay, but not quite yet. Almost. I know this is very exciting, and you're anxious to get to that part. So, you know. All right. The second part here is to determine the domain of this function. Now, let's actually make another copy of this. Clone it. And let's clear the ink off of this page. Very good. Okay, so it's very important to understand that this right here is a single function. It says f of x is equal to that, if that, that, if that, and that, if that. But it is just a single function. So when I want to find the domain for this function, I am going to focus on these things right here, because these things right here are telling me the domain of each piece of the function. Should I say that again, or are we okay? Say it again? Yes? No? Yes, okay. Hang on one second. That's fine. That's good. Okay. This right here is telling me that the domain of the function that is the piece of the function that is x squared is x less than 0. And the domain of the piece of the function that is 2 is just x where x is equal to 0. And the domain of the piece of the function that is x plus 2 is for all the x's greater than 0. So I am going to use our trusty number line to determine the domain of this function. You know what? Let's do it on a separate page so that we can see it better. I love the snipping tool. Okay, here we go. So I'm looking at these pieces right here, the domain pieces. And so I'm going to make a number line. 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so -5 and +5. And the first piece, we'll call that the green piece, says x less than 0. So I'm going to go over here to my 0 and put an open circle at 0 and make the arrow go that way. And then my next piece says x equals 0. Well, that would just be the point right here where x equals 0. Is everybody okay with that, what I just said there? And then this last piece, we'll call that the blue piece, says where x is greater than 0. So I have an open circle and it's going out that way. So when I'm determining the domain of this function, I just have to see, well, where can I cross just a single line? And I can see that anything less than 0, I'm going to hit the green line. So that's going to be part of the domain. At 0, even though it's not a line, I'm going to cross through that solid red dot. So that's part of the domain. And anything greater than 0, I'm going to cross through the blue line. So that's part of the domain. So the domain of this particular piecewise function is -infinity to infinity. Every single x value is covered in the domain of this piecewise function.
So it only has to cross one line.
It only has to cross one line in this problem. So different than when we were doing it for the logarithms. Here, it only has to cross one line to be part of the domain. So I'm going to change this just a little bit. And so you can kind of see how it might work. So let's say this x plus 2 piece was only for x greater than 2. Well, then, if that was the case, this line here, this blue line, wouldn't start until over here someplace. Let me make it look right. It wouldn't start until I was at 2. Let me see if I can get rid of this circle here. Okay. So in this case, the domain would be, I could see I go from -infinity to 0 on the green line. And then I include 0 because of the red dot. So I would be going from -infinity to 0, and 0 would be included. But then I have a space here. Everybody see the space where there's no x values between 0 and 2? No x values there between 0 and 2. Let me get rid of this dotted black line so you can, I don't want to make it confusing. No x values between 0 and 2. So that is not part of my domain. But then I start again at 2, and I would go to infinity. And then I would just unite those. So by focusing on this part of the piecewise function, I can determine the domain of the function. Kind of with me? Yes? Okay, I'm seeing mostly nods. Okay, Emma, you okay? You're looking rather skeptical.
Yeah, I'm still a little bit confused.
Ask me.
I don't know what to ask.
Okay. Then keep it in your head, and as we go along, if it kind of gets more clear, ask it. Okay. All right.
Mr. Jenkins, could
Yeah.
you repeat that?
Could I repeat which?
The step that we just did with the if x is greater than 2.
Yes, sure. Okay, so Joanna, you see how I have x greater than 0 is the green piece right here, right? You good with that?
Yes.
And you see how x equals 0 is just that red dot, right?
Yes.
Okay, but now if I'm graphing on the number line, x is greater than 2, I don't have anything here between 0 and 1, and nothing between 1 and 2. So I have to start it over here at 2 with an open circle. But then I cover everything after that because every x that's greater than 2 is part of my domain. Are you good with that so far?
Yeah.
So if I'm looking at then what is the domain of my function, all of these combined, you can see I have x values, the green values go from negative infinity all the way over here to 0, right?
Yes.
And then I include 0 because of that red dot, right?
Yeah.
But then I have a gap. I have this gap between 0 and 2. So I don't start up again until 2, but then it goes all the way to infinity.
Oh, okay, I see. Thank you.
So this gap right here is kind of where the union is, right? I mean, there's nothing there.
Yeah.
Are you sure? Yeah, that's good?
Yes. Yeah.
All right.
Thank you so much.
Did it help you at all, Emma, on that a little bit? Okay, good. Good. All right. All right. So using a number line to find the domain, take a little bit of practice and do it. But let's see if we can graph this, okay? And this is where it becomes a little bit tricky. And I have a rather unique way of graphing this, but it works for me. And if you can think of a different way, that's okay. But if you can't, then use my way. So I have 3 pieces to this particular piecewise function. And just so that you know, it is convention, the mathematicians kind of agree that they like to start it on the left-hand side, and then it goes to the right as you go down. So this would be the farthest left part of the domain, and then this would be the farthest right part of the domain. Okay, I don't take points off if you don't remember that, but it's a nice thing to remember. So I always start at the top one. And again, let's use colors here. So let's call this green, red, and blue. I'm sure that's some country's flag, but I don't know which country. Green, red, and blue. Anybody know green, red, and blue? A country? No? What's Mexico's green, red, and white? Isn't that right? Green, red, and white. Yeah. Okay. But it'd be kind of bad to draw in white on this, wouldn't it? I think that let's see what it looks like. If I can do I have white? Yeah, here's white. Can you see that? Ha ha ha. All right. Okay, here we go. No, we're gonna do green. Oh no, I don't. I'm gonna go to green here. Green. Okay. So I'm gonna start at the top, and I'm gonna ignore this for a minute, and I'm just gonna graph x squared. Okay, I'm going to graph x squared. So I know because I've been practicing my library of functions. X squared is a parabola, and I got 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And I know that it goes forever. So it's a parabola, and it looks kind of like, that's actually a pretty nice parabola I just drew there. That's the graph of x squared. Is everybody okay with that? The graph of x squared. But then I look a little bit more closely and I say, oh, wait a minute. Yeah, it wants the graph of x squared, but only if my x's are less than 0. So I'm going to go to my graph and I'm going to erase everything where x isn't less than 0. So I actually have to erase it at 0 as well and put an open circle there. So this is the graph of the first piece. It's the graph of x squared, but only for the x's that are less than 0. So let me just pause there. Questions? Kind of making sense? Those of you with your cameras off, can you at least give me a thumbs up? Or or an unhappy face or something if you don't get it. Okay, we're doing good. Okay, that's good. All right. All right, so that's the first piece. Now I'm going to look at my second piece. And it says, okay, f of x equals 2. So if I was to graph that, I know you all know that's a horizontal line because we just talked about it. That would be like that. But only if x equals 0. So again, I mean, you know, I'm erasing basically everything except for a little point right there. Where x equals 0. So that just looks like that right there. And then I go to my third piece here, and it says x plus 2. So let's remember, y equals mx plus b. Well, who remembers what b is? Who remembers what b is? Nobody remembers what b is. B is the y-intercept. Yes, B is the y-intercept. So it means that I have a graph of, I'm going to graph this x plus 2, ignoring the domain here for a minute. Well, I would start here at the B, the y-intercept. I'll make that blue now, even though it's red also. And my slope is 1 because there's an implied 1 right there. So slope means up 1 over 1, up 1 over 1, up 1 over 1. And I can see I'm going to have a nice straight line here. And that's what the graph of x plus 2 looks like. Is everybody okay with that? But it says only if x is greater than 0. So back to my eraser. All of these are less, all these x values are less than 0. Let's put my red dot back right there. And let's just make a blue open circle around it. That is the graph of this piecewise function. I graphed each piece, then I restricted it to its domain, and there it looks like. That's what it looks like. Question? No, we're doing okay? Okay, all right. So we found some particular points. We determined the domain. We graphed the function. Now we're going to talk about how do I find the range of this function. And now domain is x values. Range is y values. So when I'm writing the range, I need to start with the lowest y value and then see what I get from there. So let's ask a question here. Tiana, what is the lowest y value on this graph right here?
Is it 0?
If you take away the question mark, it's 0.
0.
Yes, it's like this, Tiana. It's 0. It's not 0. I'm just teasing with you, but only in a way. It's 0. Tiana, is 0 included or not included in this graph?
It's not included.
It is not included. So I have a parentheses there, right?
Yeah.
Good. All right. Now, this is a little bit tricky here. Jordan, you here?
Yes, I'm here.
Good. What is the highest y value on this graph?
6.
I didn't hear you.
Oh, sorry, I think my Wi-Fi is kind of bad, but I said 6.
Well, there's a arrow pointing up here. Does this stop at 6?
Would it be infinity?
It would be infinity. Okay, so this graph, I know that my highest y value is going to be infinity. Now, this is where it gets a little bit tricky, and you have to watch the graph very carefully. Are there any gaps in y values here? Are there any gaps in y values? You know, when we were doing the domain with the number line, where was it? No. Here. No, next one. Huh, where'd the domain with the number line go? I don't know where it went. Oh, well, oh, here it is right here. When we were doing the domain with the number line, if we had, excuse me, if we had a gap like this right here, well, we had to kind of fill that in with a union sign because it's not part of the domain. So looking at my graph here and the range, does anybody see a gap in y values? Right. Yes, a gap in y values? No gap in y values. Okay, we're taking a vote. Everybody has to put in the chat. Yes, there is a gap in y values, or no, there is not a gap in y values. And you can put it in, you know, just to me, or you can put it to everybody, whatever you feel like. I'm getting no's, yeses, no's. Good, I'm getting both sides of it. Good. Very good. Okay. So, for those of you who said yes, I think that you're looking at this gap right here. Am I right? That what you were looking at? But notice these are y values over here. So there really is no gap in y values here. Can you see what I'm saying? This is a little bit tricky, and it takes a while to kind of get your head around this, right? But even though it looks like there's a gap in y values, really this other piece of the function is kind of picked up for that. So the range of this function is actually from 0 all the way to infinity. No gaps, no unions. But you really have to look at the graph kind of carefully to make that decision. And we are not doing a continuous on the domain. That's something we're not going to talk about. So you can just forget about that problem. Okay, so questions? No questions. We're all doing okay with piecewise functions here. A little bit of practice will help. It really won't take that much practice. A little bit of practice will help. All right, so let me turn off the recording here. Well, I hope I didn't put anything on the recording.